So here we have a radical equation. This is coming up because this is on our test tomorrow. Radical equations, how do we solve them? We have to first, what was the first step in a radical equation? Get the square root by itself, right? And we said isolate. We said isolate the square root. Once we isolate the square root, what could we do? Close. First of all, then we have to get rid of that square root. We have to square both sides. Sometimes if you have more than one square root, we added that sometimes we have to repeat this until there are no square roots left. But first of all, you have to isolate the square root, and then you have to square both sides. Then solve for x. And with a radical equation, we always had to check or verify. So let's do this one off to the side. We have our instructions still here, except for the repeat part didn't come in, but we don't need to repeat in this case. This is 187. Thank you. So now we have a square root. Is it isolated all by itself on one side? No. It has an additional plus 4 here. So step 1, you'd subtract 4 on both sides. So now we need to square both sides. When I square both sides, the whole side gets squared. So here, squaring and a square root, that will just go away. You'll just be left with x, 6 minus x. On the other side, when you square x minus 4, you have to remember that means x minus 4 times x minus 4. So you're going to have to FOIL, multiply everything out. You're going to get x squared minus 8x plus 16. Right? When we do this times this, minus 4x minus another 4x plus 16. Combine the like terms and you'll have minus 8x in the middle. Now, what happens, and the reason this question is in this chapter too, is sometimes when you square both sides, you end up with an x squared. See how we end up with an x squared? This makes this a quadratic equation. So when we see a radical equation, we want to train ourselves to think, oh, I've got to isolate and square both sides. When we see a quadratic equation, how do we solve those ones? Make one side equal to 0, and then we can factor. So here, I can subtract 6 on both sides, add x to both sides, and I will make one side equal to 0. And the reason we want to make one side equal to 0 is so we can use the zero product property. Because now if I can change this from adding and subtracting to two things that are multiplied together, and for factoring this, it would have to be x and x. Two numbers that multiply to 10. 5 and 2. Do the outside and inside ever make 7? Yes, so we'll go 2 and 5. They would both have to be negative to make the negative 7. Quick check, do my last ones make positive 10? They do. So this works. So then we've changed it to multiplying, and the zero product property says, well, if two things are multiplied to equal 0, either this first one has to be 0, in which case x would equal 2. Or the second one would have to be 0, in which case x is equal to 5. Now, because this was a radical equation to begin with, we have to remember that we need to verify. Ooh, that pretty? So nice. So we're going to have to check both of these. So what I'm going to do here at the bottom is I'm going to check You always have to verify radical equations. You don't have to verify quadratic equations, but since the original, if it was just this question, if it just started here, you wouldn't have to do, both those answers are right. But because our question started up here as a square root equation, a radical equation, we do have to verify. So we're going to go and we're going to verify the x equals 2 first. So you split it up, you do your left side, you do your right side, you go back to your original equation, which on the left side had root 6 minus x, so it would be root 6 minus 2 plus 4. And our right side original equation was just x, which would be 2. 6 minus 2 is 4. Square root of 4 is 2. So this becomes 2 plus 4. 2 plus 4 happens to be 6. Everybody knows 6 is equal to 2. Whoa. That doesn't work. So this one is extraneous. It doesn't actually work. Now we're going to check x equals 5. Left side, right side. And so we'll plug in, we'd have x minus 2, is that what it is? Plus 4, is that the original equation? Or was it, no, 6 minus x. Oh, okay, no, that's better. 6 minus 5 plus 4, and on the other side it was just x, which would be 5. 6 minus 5 is 1. The square root of 1 is 1. 1 plus 4 is 5. So that one works. So we have one extraneous root and one root that works. Does anyone know why these extraneous roots come out in radical equations? What's happening? The mathematical problem happens at this step right here. There's a possibility of a problem because you can start with two things that aren't equal. These two things aren't equal. Negative 3 does not equal 3. But if you square both sides, what happens? They both become positive 9. So they appear to be equal here, even though they weren't equal before. So at this step, right here, when we square both sides, which is the only way to solve radical equations, to get rid of that square root, we could have possibly had on this side positive, on this side negative. Check what happens out when I plug in 2. 6 minus 2 is 4. Square root of 4 is positive 2. But 2 minus 4 is negative 2. So at that point, they weren't equal, but when you square both sides, they would become equal. So that's the reason we always have to verify with square root equations, because you could have had two things that aren't equal become equal after squaring both sides. So we have to check to make sure that they work. I can move it down, yes. So there's the check. Find the questions. What page do you do this? 187? Yeah. Square root of 1. And square root of 1 is 1. Yeah, because 1 times 1 is 1. Yeah, and then that becomes 5. So that one works. Okay, number 12 is a radical equation. I'm going to give you time to try that right now because it is on your test tomorrow. Your test tomorrow, though, won't have a quadratic appear. It'll just have a regular linear one without having to factor.